Good morning or good afternoon, depending on where you are at. My name is Atarot Azizi Namini, Director of the ABC UTC at Florida International University.
Our presentation today features the New York State Department of Transportation's use of ABC and digital delivery for the East 138th Street Bridge Replacement Project in New York City. We're pleased to welcome our presenters, James Flynn, Director of the Office of Structures at the New York State Department of Transportation, Brenda Crudele, Director of the Structures Design Bureau and the Structures Specialty Engineering Bureau, and Julianne Fuda, Assistant Director of the Structures Design Bureau, both also with the New York State DOT. In addition, would like to introduce our Q&A session moderators, Paul Lyles, formerly Georgia State Bridge Engineer, and Jugesh Kapoor with WSP USA and formerly State Bridge Engineer at WSDOT. Jim?
Thank you, Mary Lou, and welcome everyone. As Mary Lou said, my name is Jim Flynn. I'm the State Bridge Engineer from New York, and I'm happy to be presenting with Brenda and Julianne on East 138th Street Bridge Replacement Project, a marriage of accelerated bridge construction and digital delivery. I do have over 30 years of bridge experience, as noted in the slide, and two of our superstars that I'll be presenting from the Office of Structures, Brenda Crudele, who has over 20 years with New York State Department of Transportation and is currently our Structures Design Bureau head, and Julianne Fuda, who has over 13 years of bridge engineering experience and is the Assistant Director of Design. So on the agenda today, we're going to be talking about New York State DOT and accelerated bridge construction in general. And then we'll get into digital delivery at New York State DOT, including two pilot projects. The first one was Route 28 over Sopus Creek, which is now completed, and Brenda Crudele will be presenting on that. And then we'll get into the pilot project number 2, East 138th Street over the Major-Deegan Expressway, which is currently in construction. And Julianne will talk about a project overview and comparison of pilot projects, utilities and clash detection, which is really interesting, staging and accelerated bridge construction, and 3D modeling. We'll get into the future vision of digital delivery at DOT, and then we'll open it up for Q&A. I'd like to give at first a brief introduction on the Structures Office at New York State DOT, and I always like to talk about our mission when we start off talking about structures. We do have oversight on the structural portion of the department's capital construction and maintenance programs, and we are always focused on safety. New York State DOT is located in New York, of course. New York is in the northeast quadrant of continental US. There are 11 New York State DOT regions. The main office, New York State DOT Office of Structures, is in Region 1 in Albany, New York. And we do have oversight on all the other structural portions throughout New York State. New York is unique in that it borders not only the Great Lakes in Canada, but also the Atlantic Ocean to the southeast. Within the Office of Structures, there are 4 distinct bureaus that I have oversight on. There's the Structures Design Bureau, which Brenda Crudele leads. It's staffed with about 60 engineers and technicians, and they design a variety of structures from simple to complex, and not only bridges, but we get into design structures, culverts, various other structures as well. Then there's the Structure Specialties Engineering Bureau, where Brenda Crudele is right now doing double duty, and that's essentially our construction bureau. We have our metals unit, fabrication and construction, concrete fabrication and construction, handling construction issues in the field, and also our hydraulics unit. We have our Structures Policy and Innovation Bureau that Harry White leads. That's split into 2 main focus areas. One is setting standards for New York State, including updating and maintaining our state bridge manual for design, our bridge detail sheets, which are detail sheets that assist designers in laying out plans. And then separately, they are heavily involved in design build in New York State, especially on the structural portions with RFP development, reviews of proposals, and then in construction and design review of issues that come up. Lastly, we have our Structures Management Bureau. Paul Campisi is the bureau head, and he has oversight on inspections statewide for New York State with bridges. We do both state and local bridges, as well as overhead sign structures and large culverts that are state-owned. So, how are projects chosen for ABC at New York State DOT? Type of ABC is determined by, of course, traffic impact and detour length, obviously focus areas when you're talking about the need to accelerate construction. Cost premium is always balanced against those needs, and community development is always considered as part of that equation. Often we think about accelerated bridge construction in heavy traffic areas with large detour lengths, or just something that's really not achievable without doing accelerated bridge construction. But through community development, there are projects that maybe aren't necessarily high traffic areas, are huge detour lengths, but through community development, we find that we do have to accelerate the construction to meet the needs of the community at hand, and also other factors that are observed throughout our process. Particularly in our high density areas and mainly New York City, we generally require them to say why ABC is not being used, just because of the high volume of traffic within New York City. New York City is a high bridge need area, and we do a lot of projects there, so we're always looking to accelerate projects in New York City. We have developed standard details with acceleration in mind, and we'll go through some of those details now. Probably one of our preferred, which it is our preferred details, is the integral abutment standard. This can either be constructed with precast or cast in place components. Typically we do a cast in place, but it has been done precast. We are showing a steel integral abutment construction detail here. We also do it with precast pre-stressed beams as well. What makes this accelerated is that as compared to a conventional abutment, cantilevered abutment, you don't have a footing, it's rectangular pours, we don't have to deal with pedestals, and it's very straightforward construction. You put the piles in and do a few pours, put the beam in, and then you're onto your deck and approach slab. So just in essence, through the fact that you've reduced pours, it accelerates construction. And also what's very nice about this type of construction, why we like it a lot in New York, is hydraulic failures is our leading failure of bridges in New York State by far. And this is a very resilient structure. The superstructure is tied into the substructure, and it's been proven through flooding events to withstand those very well. Next up are precast next beams, which we do have standard details for. It's essentially a double T pre-stressed precast beam. You can see one being erected here. They can either come with the deck integral with the flange or the flange separate from the deck, depending on the needs of the project. They are set, and then there's a closure port put in place. Typically, we will diamond grind, do a UHPC closure port, diamond grind, and put longitudinal grooving into the deck at that point. One of our earlier precast deck panel projects, which utilized UHPC, is being shown here. You can see pockets for shear studs, but also you can see where the connections will be made with UHPC between the precast deck panels. You can note, and I'll show this in a separate picture, how tight those joints are, the connection areas where the UHPC will go due to the inherent nature of UHPC bonding so well. We can use shorter bond lengths for the rebar, development lengths, and then use tighter closure pores. This is an example of a closure port being poured with UHPC. We did look recently to see how many projects on the national website have been done with UHPC throughout the USA. Per the website, there was 260 total projects. New York State had about 40% of those at 61. We like to say we're a leader in utilizing UHPC. We're always looking to find new ways to utilize it. And this is certainly a predominant way we have to date. And just an example of a finished product with the precast deck panel connection with UHPC after it's been diamond ground and longitudinal grooving has been put in place. You can see it's very well bonded. It will have a low permeability, and we expect it to be there just as long as the panel decks adjacent to them. This is a prefabricated bridge unit photo. Fort Miller fabricates these in New York. Essentially, it's kind of the steel version of the next beams. They do fabricate these inverted with the steel beams on top of the deck and flip them over. It does allow for some pre-compression in the beams before delivery. And then they're delivered to the site and erected in a similar fashion as the next beams, where they're set side by side and there's closure pores put in place. Typically, we diamond grind, longitudinal groove, and then we're ready to go. One of the more unique accelerated bridge construction things we've done in New York, which is just kind of neat to highlight, is our roll and slide in superstructures. We've done a few of these. It does require assembly adjacent to the structure. It requires the ability to construct, demolish under traffic or additional closures. And what we're showing here is ID4 over Dingle Road in our Poughkeepsie region. It was actually 2 bridges on the interstate that were slid in over 2 different weekends. You can see in the top right of the photo is the structure ready to be slid in as they demolished the bridge in the weekend. We were successful on both bridge projects. They did keep one direction of the interstate open while they diverted traffic onto a state route around this project on the weekend. There was a lot of public information outreach ahead of this. It was very successful on both slide-ins, and the project was completed, each project in a weekend. Brenda?
Thanks, Jim. So now we're going to jump into digital delivery at New York State DOT. So starting off, what is digital delivery? So we're all very familiar with the current process of how in design we model our bridges, we model our highways, we create 3D models, we take that information and we use that to create our 2D PDF plans that the contractor uses to bid on. They bid on that information, and then a lot of times they recreate their own three-dimensional information from the 2D plans to construct the project. So what digital delivery is for us, it's being able to specify contractual work with a variety of relevant electronic files. So instead of taking our smart information and dumbing it down and flattening it down to plan sheets, we're making the electronic information models as the legal contract document and giving that directly to the contractor. So we started this at New York State DOT back in March of 2018, where we formed our model-based contracting committee. We had the following objectives listed here. We wanted to see what other states were doing. We wanted to identify issues that we would see with progressing a model-based contracting project at New York State DOT. We determined our goals, and then we attained executive approval to move forward. One of the big things that I like to point out here is that we had representation on the committee throughout the whole department. So we had main office and regional staff involved. We had staff from structures, highway design, office of construction, our legal folks and our contracts folks were all involved in the committee so that everybody had a say in what we were doing. So the two goals that we had for our pilot projects, the first one is to create a process to include the models as the legal contract document. So that's something that we have accomplished with our first pilot project. We like to check that one off. You know, we always like to finish things in committee, so that's something that we've accomplished. And then our second goal was really to leverage technology to explore more efficient ways for us to do business. And that's not as easy to mark as checked off. That's an ongoing goal that we have, and it continues to change. And we're really looking to focus on moving our information from design to construction and then into asset management. So our first pilot project was the bridge replacement of Route 28 over the Esopus Creek. This project is located down in the Catskill Mountains in Lower New York. Our design schedule took place in 2018 and 2019. It was awarded to the contractor in 2020, and construction took place in 2020 and 2021. So I like to point out that the design for this project was completed with all in-house staff, both structures and highway design. We really wanted to dig in and learn the digital delivery process and develop that process ourselves. A lot of other states have hired consultants to do that work for them, but we really wanted to lead the effort internally at DOT. So you might ask yourself as how do we make that information model the legal contract document? And we went about this in a pretty simple way we changed the definition of the term plans in our contract. So currently, the definition of the term plans is the official contract drawing, which is show the location, character, dimensions, and details of the work to be performed. So that's in all of our contracts. What we added for our digital delivery contracts is we stated that the plans will also include any electronic files identified as plans. This may include engineering models, spreadsheets, CAD files, or other electronic files. So the idea here is we wanted to leave ourselves the flexibility that we could specify any electronic file we wanted as the legal contract document. So what we did is we looked at all of the components of a project and we asked ourselves, what is the most efficient way to transfer this information to the contractor? So you have plan sheets, physical models, or data models. And looking at all the information that we give to the contractor, we decided that all three of those are good ways and efficient ways to transfer different information. So we ended up taking a hybrid approach with our project. And we looked at each component and essentially did a return on investment of what is the best way to provide that information. And the example that I like to pull out and show is bridge railing. So we have standard details for our bridge railing that our fabricators have been using for decades, right? So we could take the time and model every nut and bolt on that railing, but they're just going to go back to our standard sheets anyway. So we didn't feel that that was a good use of our time to model that when we know that they're going to use our standard detail anyway. So here's a list for our first pilot project of what we included as electronic files. So we tried to push the envelope and we tried to include as much as we can. So on the bridge side, we included our substructure elements, abutment, piers, pile, concrete, rebar, the superstructure, the steel girders and the deck, our approach slabs, and all of our bridge excavation embankment. On the highway side, all the project geometry, horizontal and vertical and super, all the highway corridor, the pavement, sidewalk ramps, all the earthwork quantities, and then our utilities and closed drainage. The components of the project that we thought were still a good way to transfer information is plan sheets, title sheets, PE stamps, index, notes, tables, right-of-way, railing details. So we went through and these are the things that we still delivered as plan sheets to the contractor. So how did we, essentially assign files to be electronic files identified as plans, like we said in the definition? So what we ended up doing is we had a new plan sheet that we added to our set, and it's called electronic files identified as plans. We listed out each file that was contractual, and most importantly, you can see we added a date and time stamp for each file. There was a lot of discussion on how you know whether you have the right file. And this is how we address that, is that each file came with that date and time stamp, and it had an engineer record along with it. And you'll notice on the bottom too, we have a spot for field revisions. So we follow our same process for field revisions that you would for plan sheets, but just with the electronic file. So we also included a special note with our projects. So you can imagine that if you're looking for certain information on the bridge, you know where to go in the plans to find that information. You don't need special instructions to tell you where that is. But in a model, this is all new to everybody. So what we did was we went through and gave specific electronic file content for each of the following components of the bridge. And one example that I show here is for the structural steel. So what we do is we go through and essentially we tell them what information they can find in the model. So in this case, girder plate thicknesses, plate lengths, diaphragm types, gusset plate thicknesses, that information is all included in the model. But almost more importantly is the information that you can't include in the model. So stud shear connector dimensions and spacings, welding details, splice locations were not included in the model, and those were provided on plan sheets. So we found it was very important to include this special note for all the components of the bridge so that people can find the information that they need. One thing we were looking to see if the fabricators were also interested in model-based shop drawings. So this project, it had the bridge. We also had a precast culvert in the contract. So we included a note in the plans that allowed for the fabricator to submit model-based shop drawings back to us if that was their preference. It turned out that neither fabricator did that. We got standard 2D shop drawings, but we did allow for that innovation if the fabricators were ready for it. So how do we end up delivering, the same information in the model as we would in the plans? So the contractor still needs all the same information. We're just delivering it and packaging it in a different format. So we did this 3 different ways throughout the model. There's a function called item types, which allows us to attach metadata to information within the model. We had save views. which allows the user to call up preset views. And then we had embedded links attached to other files. So an example of item types is shown here. If you're in the model and you click on the pile, you have information that pops up. So you can see that this is pile number 8. It's a cast in place pile. The batter is a 6-on-1. And then most importantly for us was the item information and the specification number that goes along with this. So you can see here's our item number for the pile, the description, and any comment that goes with this. And this is important because it tells the contractor how they're going to get paid, and it attaches the specification required to each component of the model. The next is Save Views. When you do jump into this full model, it can be overwhelming. There's a lot going on. So being able to pick out a particular view where it turns everything else off in the model is super useful. So here you click on Begin Abutment Rebar, and now you just have the begin abutment and the rebar in that, so you don't have to be distracted by everything else in the model. And then the last way we use to convey information is with embedded links. So we had a couple locations in the model where you can see those blue spheres we had on there, and there was different PDFs that were attached to the model. So if you're interested in those railing details that we provided as 2D plans and you wanted to see what those are, if you click right on the model, it'll open that PDF right up for you. So I want to just talk real briefly about contractor outreach that we did for our first pilot project. So we knew that this is very different for our contractors, and we wanted to give them a heads up and make sure they knew it was coming. So we had 4 in-person meetings that were simultaneously webinar held prior to the advertisement of this project. Our plan specification and estimates were due into our Design Quality Assurance Bureau at the end of September of 2019. And I think one of the most important things that we did for this project is we posted our PS&E information online on our contract website prior to advertisement, and about 2 months prior to advertisement. And based on our AGC meetings, we let everybody know that we were going to do this. And what this allowed is it gave the contractors an extra 2 months to see the files, become familiar with the project, and really they could have started estimating 2 months earlier if they wanted to, prior to the actual advertisement of the project, which was in December 2019. So we held our letting in January, and we got very favorable results. So we had 5 bidders that bid on it, which we thought was fantastic for this project. And you can see that the first 3 bidders for a $23 million project were within about $28,000 of each other. So we were very happy with these results, and we like to say that it was so accurate because the models are the best way to get the information to the contractor. They had all of our design information ready to go. Okay, so some positive feedback. So we have finished construction of this project, and I'll just run through what we've heard from the contractor, fabricator, and our construction inspection staff real quick. So everybody really liked the fact that it helped with the visualization of the project. It was used by our CI staff, the construction staff, and we also used it for local homeowners too that had their houses nearby to the project. Everybody was able to instantly measure quantities and get information. It was very easy for everybody. The GPS units that they used were great for confirming elevations and resolving conflicts. The supplemental surfaces, so like bottom of culvert, sub-base, subgrade, are really helpful. They go into the machines very well. And we were told it was easy to review the design intent and answer questions in the field without submitting RFIs. We saw no delay in getting shop drawings approved by New York State DOT, and the job was finished on schedule with no delay. Some of the lessons learned that we had. So we found out that Bentley is not completely interoperable with AutoCAD. Some of the fabricators were using AutoCAD instead of Bentley, which is what we used for our information models. We found that bouncing back and forth between the model and the plans can be confusing. There is a lot of information provided in this contract. And again, we weren't sure if all of the information was being fully utilized because there was a lot of information. The contractor was very interested in more than just a finished grade model. They would have been more happy with a construction stages model and different sequences. So once they got into using the surfaces, they really liked those. One thing that we heard was the deck cross slope is not very easy to get out of that model. And some software with the capability of cutting cross sections would have been really helpful. And then we found too that we need construction staff out there that are comfortable with reviewing and using the model to obtain information. We knew that going in, and we made sure to staff accordingly out in the field, but it was very obvious that construction staff need to be able to use the model. So just go through real quick. This is a screenshot of the model from the design model. And then next we'll see as built in construction, and then you overlay the two on top of each other, and they should look the same, and they do. So we like to call this project our proof of concept. So you can say that the project was biddable and buildable. We got the product that we wanted out of this. Like I said, we came in on time and on budget, so we were very happy with the completion of our first pilot project. So with that, I'm going to pass you over to Julianne.
All right, thank you, Brenda. Good afternoon, everyone. Now I'd like to switch gears and talk about our second pilot project that's for East 138th Street over the Major Deegan Expressway. So as you can see, I like to show this photo that compares our two pilot projects. So the Route 28 over Esopus Creek, you can see it's very rural setting. It's really a lot of space for staging, for work zone, everything here. And then looking at our second pilot project, very tight quarters. There's a lot of utilities and staged construction that really mandated the use of accelerated bridge construction techniques for this project, where we used modular deck beams. So here's an overview. This is located down in New York City in the Bronx. The design schedule was designed in 2020. Contract was awarded middle of 2021, and construction has begun and is expected to last through 2024. And just like our first pilot project, we're very proud to say that this bridge replacement was designed with in-house staff with the Office of Structures and our Office of Design for the Highway Group. But we did bring on a consultant to help with the utility relocations for this project. So here's an aerial view of the existing bridge. This is East 138th Street. It crosses the Major Deegan Expressway, and it is just 25 feet from the approach to the Madison Avenue Bridge, which is one of the few free entry points into Manhattan, seeing more than 150,000 vehicles per day. The existing bridge is a two-span steel girder structure built in 1938. The existing bridge has very limited vertical clearance over the expressway and has been hit numerous times. So the project goal here is to replace the existing bridge, eliminate the pier, and increase the vertical clearance. And this must be accomplished all while providing for pedestrian access, keeping all lanes on the bridge and abutting intersections open during construction, limiting impacts to the various utilities, and providing aesthetics that tie into the historical character of the surrounding area. The second pilot project was challenging from nearly every aspect, and it really was an ideal candidate for model-based contracting, given the amount of coordination and clash detection that is necessary for a project of this scale with so many site constraints and strict geometric controls. So the East 138th Street Bridge may look very uncomplicated at first look. However, there are many complex traffic utility, geotechnical, and structural design challenges that needed to be overcome to ensure the success of this project. So here is our bridge. It is actually much wider than it is long. It provides for accessibility to 6 lanes of traffic, along with bike paths and sidewalks to accommodate the high pedestrian demand in this area. The site is equally congested below ground as it is above ground, with a very complicated web of utilities. And really, there's every type of utility imaginable within the project limits. So you can see this is our bridge here. So our girders are running in this direction. We have utilities that are carried across the bridge. We have utilities. This is a combined sewer that actually runs below the abutment underneath the expressway to the other side of East 138th Street. And we're going to go into a lot of detail later on in the presentation about just how challenging it was to accommodate that sewer. So let's just talk about some of the differences between our 2 pilot projects. So the design for the Route 28 over Esopus Creek, that was our first project. That was designed in 2018, 2019. And construction was completed in 2020, 2021. So during construction of our first pilot project, we started design for our second pilot project. And like we said, our East 138th Street is currently in construction. Differences between the two, Route 28 was built in a very rural area. There was no underground utilities in comparison to East 138th Street, very congested urban environment with a sophisticated web of underground utilities. Route 28, we only had 2 different agencies to coordinate with, versus down in New York City, we had over 10 different agencies that needed to be coordinated through design and construction. Route 28, our first project, was built using a single work zone traffic control stage, and East 138th Street had over 10 different work zone stages to build the entire project. And finally, one of the major differences between the two, like Brenda mentioned, for Route 28, we modeled all of the structural steel in 3D and transmitted that as contractual information to the fabricator. And one of the major changes that we made was based on lessons learned. We reached out to the fabricators after the project was completed, and one of the recommendations they made is that they were very hesitant to use the 3D model for the fabrication of the structural steel. So if you think about in the 3D model, you need to go and you need to measure everything, measure your flange thickness, locate your flange transitions, measure your plate widths, etc. So, we heard them loud and clear, and because our second pilot project was in design during construction of the first one, we were able to make this change, and we ended up using Excel spreadsheets to convey the contractual information for the structural steel on the second pilot project. So we still modeled all the steel in 3 dimensions so that we could have that visual component for clash detection. We just provided that information as supplemental information to the contractor. So all of the contractual information was given in a tabular format, which is a little closer to what they're used to seeing in a 2D plan sheet with a girder schedule. So looking at the utilities, these are all the various utilities that are located in our project limits. We had Con Ed, we had electric conduits, we had a gas main, we had Verizon Communications for telephone and internet. We also had New York City DEP water and sewer. We had New York City street lighting and New York City traffic signals. And really what was very beneficial using digital delivery for this. This is a conventional, maybe what you would see utilities shown in 2D and plans. At New York State DOT, we show all of our utilities in color to help really bring out that line work so that it's not lost with leader lines or other component information on the drafting plans. But even though they're shown in color, yeah, you're not going to miss them, but it's very difficult to see where these are in relation to each other in space. So looking at how we modeled all of the utilities in 3D for East 138th Street, you can see here we start with our overall 3D model, and you can start going in and turning off different levels. So you can really isolate the structural components you're looking for and the utilities where their locations are relative to the bridge itself and relative to each other. So this was extremely valuable for this project. And one of the biggest takeaways that I saw as a designer being able to use 3D models for utility coordination is looking at clash detection. So here is a very preliminary model of our bridge abutment. So this is the bridge back wall here. So our girders are running this direction. You can see some of our deck reinforcement that goes from the deck into the back wall is shown here. And these are all of the various utilities that need to penetrate through the back wall and be carried across the bridge. So we coordinated very closely with the utility companies, the consultant that was on board helping us with the utility relocations. We had all of our meetings just like you would if you were working on a conventional 2D plan project. You know, we double checked, triple checked our numbers, had sketches passed back and forth to review everything. But once we put everything into 3 dimensions and brought everyone's models together, you can see these are the penetrations in the back wall where the utilities should pass through. And you can see every single one of these utilities was not in the right location. So even though we did our due diligence with that coordination, you know, if we didn't model these in 3D, we wouldn't have found these conflicts until we were in construction. And the more conflicts and errors that we can correct in design, the less money you're going to spend and the less time it's going to take you to correct those issues rather than if you waited until the project was in construction. So here is a rendering of our finished model. So again, here's our back wall, this is our bridge, this is our deck, and you can see all of the utilities are penetrating through the back wall in the proper locations. So I think that's a great example to show the power of 3D modeling and digital delivery. So because this project is located in a tight urban environment and we had incredibly high traffic and pedestrian demand to accommodate during construction, it really proved to be a challenge for developing the staging for this bridge replacement. So what we ended up with is a staging plan that would replace the bridge in 4 independent stages over 3 years while using accelerated construction techniques. So the first stage is that we're going to go out, do all of the utility relocations. Once the utilities are in their final resting place, then we can start our bridge construction, which would be completed in stages 2, 3, 4, and 5. Once the bridge is built, then stage 6 through 10 is the work along the Major D and Expressway and finishing any remaining highway work on East 138th Street. So I want to talk a little bit about accelerated bridge construction and why that was very important for this project. Like Jim mentioned, any New York State DOT project in an urban environment must provide justification for why the project is not utilizing any accelerated bridge construction techniques. And here in New York, we have a driver's first initiative. So in September 2012, the governor initiated this new approach to prioritize the convenience of motorists to ensure that disruptions are as minimal as possible to drivers at highway and bridge projects across the state. So following our Drivers First initiative here at DOT, we decided to proceed with prefabricated modular deck beams with UHPC closure pours for this bridge replacement project. So I know everyone here, you understand the advantages of accelerated bridge construction, but I just want to do a quick comparison here for the techniques that we chose for this project, and the alternative would have been conventional steel girders with a cast-in-place concrete deck. So the first thing that we all know, it's right in the name, accelerated bridge construction. With prefabricated modular deck beams, you have very minimal cure time for UHPC versus the in-field application using cast-in-place concrete. You're going to have at least a 28-day cure time. So you have immediate savings there. The next is quality. So because we have so many different stages of bridge construction, with 4 different stages, if you're going to use a cast-in-place deck, those sections of your deck are going to be cast at different times of the year and in different years. So you're likely going to have 4 different qualities of a deck on a single bridge. Versus using the prefabricated modular deck beams, all of the stages for all the units are going to be cast in the fabrication facility. So you have a lot more control over quality there. There's a major cost savings, especially the more construction stages that you have. So for the prefabricated modular deck beams, yes, you need multiple mobilizations for erection of those units, but that's going to be the same for the steel girder option. So whether you're doing precast or cast in place in the field, you're still going to have to bring those cranes out at every stage for erection. But where the savings really is if you were to do a cast in place concrete deck, you would have mobilizations for your steel erection, but you would also have that additional mobilization for your cast in place deck placement and finishing operations. So going with the precast option, we had substantial cost savings. Probably most importantly is safety. You know, the less amount of time that we can spend in the field with our contractors working in a congested urban environment, the more safe that the project is going to be. Having prefabricated components, those are constructed in a controlled setting instead of out in the field adjacent to live traffic. And finally, durability is very important. So we've had very great success with UHPC components and closure pours here in New York State. We know that they're highly durable. And you know, another alternative, if you were going to do a cast in place deck construction with traditional closure pours, you know, you could use a rapid set concrete or grout, but we found that you end up trading time for durability. So you may be able to open that up to traffic sooner, but you may be sacrificing durability in that case, where with UHPC, you get the reduced cure time as well as the high durability. So let's take a look at the staging here, the 4 bridge stages. So you can see in stage 1, we're utilizing the existing bridge to carry all of the traffic while we build the new portion. Stage 2 and 3, we're going to be utilizing traffic on existing and on the proposed structure. And then finally, the last stage, this has the combined sewer carry beam system, which we're going to talk about here sooner. But really, you know, using these visualizations from our 3D models were very advantageous during the design. We were able to convey to project stakeholders exactly how traffic would be maintained, ensuring their buy-in and cooperation. The middle bridge stages were very narrow, which did add cost and construction time to the project, but it really allowed us to maintain our traffic keeping all lanes open at all times. Okay, so let's talk a little bit about our superstructure. So here's our framing plan. So again, our bridge is much wider than it is long. So our primary longitudinal girders are running from left to right on the screen, and we have all of our diaphragms placed along the skew transversely. We can see that they're broken up by stages here. Again, our middle 2 stages are very narrow compared to the outer 2. Because we had so many different utilities that are carried across the bridge, each required a unique utility support to be connected to the steel girder. So all the utility supports are shown in color here. Some utilities were hung from above. So here's an example here where we had a utility strut at the top and the utility could be hung below that. We also had situations where the utility struts were located near the bottoms of the girders and our utilities could be supported from below. Because we were using the prefabricated modular deck beams, so that's 2 steel girders that are connected with a precast deck and then erected before the UHPC closure pours. We did actually have some locations where utilities were going to be located within a modular unit itself. So we did have in some locations temporary girders that were to be in place during transport and erection. And then once all of the units were tied together with UHPC and that UHPC closure pour cured, we could then remove the temporary diaphragm and we had our utility strut to occupy that space. Looking at the substructure, it was also constructed in 4 different stages, but one very unique aspect of this project, given the very tight urban area, there was not a lot of room for the contractor to physically do the work. So one solution that we came up with here is that we would utilize the existing bridge deck to excavate and pour the foundations for the proposed structure. So you can see here that we proposed having temporary supports erected along the far right lanes of the Major Deegan Expressway that would then support the existing structure for their construction equipment to demolish the existing abutment, install the proposed foundations, and install the proposed abutments, all while working over live Major Deegan Expressway traffic. So looking at the substructures and foundations, we had the subsurface profile was very unique, given that it was near the river down in New York City. The bedrock elevations actually varied very significantly across the project site. So at the begin abutment, we had driven solutions where the rock was much more deep. We used driven H-piles. Driven cantilever sheeting for excavation support. And then by the time we got to the end abutment across the other side of the expressway, bedrock was very shallow. So we used drilled solutions. So we had drilled shafts that were reinforced with an H-pile. We had drilled shafts with permanent casing and rebar cages. And then our excavation support, we used soldier pile and lagging walls with grouted tiebacks and whalers and geosynthetic reinforced walls as well. So one of the most challenging aspects of this project was what we like to call our carry beam system. So if you remember, one of the first slides I showed you was a green combined sewer. This is a 30-foot wide sewer that runs underneath the East 138th Street, dives down, crosses the expressway underneath our bridge, underneath the abutments. And this was a New York City Department of Environmental Protection, DEP sewer that could not be impacted during construction. So this is a 30-foot wide sewer that could not physically be impacted, and we could not load at all during construction or in the final case. Now, while that seems very challenging in and of itself, DEP actually had plans in the future to widen this sewer. So not only did we need to clear this existing 30-foot wide sewer, they had plans to make this a double barrel sewer in the future, and we needed to maintain a 60-foot wide clearance envelope in this area for them to go out in the future after our bridge has been built and open to traffic to potentially excavate and undermine this area, all without disrupting traffic overhead. So what we came up with here is this carry beam system. So you can see here we have a 3-beam system in cross-section. We have diaphragms, we have lateral bracing as well, and we have these lagging piles that are hung off of the fascia carry beam, and these are going to act as earth retention devices. So here's a rendering of our 3D model. So again, this is the length of our abutment. Our bridge is crossing overhead in this direction, and the sewer is going to be underground in this direction. So we have our 3-beam carry beams that are going to take the load of our abutment and transfer them to drilled shafts. And then we have these lagging piles that are hung to retain the earth in this area. One aspect that was very challenging is that this carry beam system not only had to be designed for gravity loads, but also for lateral earth pressure. So that was very unique. So let's look at a rendering here. So here again, this is our 30-foot wide existing combined sewer. This is a branch interceptor sewer, and the combined sewer is going to be 60 feet in this direction here. So this is the area that we had to span. This shows our temporary excavation support. So we utilize soldier pile lagging wall. So we have our soldier piles, our timber lagging, and we have whalers, braced excavation with tiebacks going in and out of the screen. So the first thing we do is we install 2 drilled shafts with a concrete pedestal on each side, and this is really going to be the limits of our clearance envelope. So our carry beam system will be supported by these drilled shafts and will span over this entire area. So the sewers that are shown now are existing, and we've left them plenty of clearance envelope for a future widening. So the carry beam system is shown in blue. That is placed. We have our lagging piles that are going to hang from above, not impacting any of the sewers underground. Carry beam system is then encased in concrete. the proposed abutment is poured on top. So we have our footing, our stem, and our pedestals for our prefabricated modular deck beams. And then in the final construction stage, a final toe wall is placed, and this is all hidden from view, and no one is ever going to know just how much complexity, how much structural engineering went into everything behind this wall. And really, having the three-dimensional information models really enabled our designers to be confident that the proposed solutions that we put forth in the contract documents are constructible. I think it would have been very challenging to try to depict our carry beam system and the construction sequence on conventional 2D plans, but being able to model all of these components and see how they all fit together really gave us a lot more confidence that this would be buildable. And finally, since this bridge is situated at the quadrants of a major urban expressway with ramp intersections at each quadrant, the geometric tie-in points became a major challenge. And we were able to tackle this challenge with the help of 3D modeling at each unique corner details of the bridge. So here's a view. This is the corners of our prefabricated modular deck beams. So this is 1 unit, this is 2 units. And what we decided to do is we actually pulled back the precast deck in these areas. And this was really so that we could satisfy the strict ADA compliant pedestrian ramp requirements. So to fulfill all the geometric constraints, like I said, we had held back the deck in the 4 corners of the bridge, and we made those cast in place. So the reinforcement for these sections were placed in the field for the deck, for the sidewalk ramp, and for the barrier. Then all of these sections had their cast in place deck poured after all of the units were erected and the UHPC closure pours were cured. Then we poured the sidewalk and the approach slabs. We came back and poured our barrier. We had aesthetic treatments where we added granite facing and granite blocks to tie into the historical retaining walls at each corner of the bridge. And then we finished with our final lighting, bridge-mounted signs, signals, and utilities. So really, I like to stress the importance of the work that our in-house staff are doing here at New York State DOT. And we were recently recognized at Bentley's International Year in Infrastructure Conference, where we received the Going Digital Award in the bridge category for the East 138th Street Bridge over the Major Deegan Expressway. With that, I'm going to turn it back over to Brenda.
Julianne. So if anybody is interested in our contract documents for either of our 2 pilot projects, they're very easy to find on the internet. So all you need to do right now is just jot down the 2 contract numbers. So our first one is D264093 and our second is D264507. Once you have those 2 contract numbers at hand, if you go to do a Google search and just put in New York State DOT contract documents along with the D number, that will bring you up to our contracts page where you'll be able to get the full contract, which includes the models that are the legal contract document, but it also includes all the other supplemental information that goes along with it. So if you're interested, you can see how we actually put our contracts together. So I just want to talk real briefly about our future vision of digital delivery at New York State DOT. So what's really holding us back at this point? And really, it's the lack of data interoperability that we're seeing. There's a lot of projects going on nationwide with FHWA and AASHTO that are working to tackle this problem. It's a large problem. Currently, there's a pooled fund study, the BIM for Bridges and Structures, that is completing up its first phase and starting with its second phase, and that's tackling on the bridge side. There's a BIM for Infrastructure, which is a pooled fund that's tackling the highway side, and they're all working to work towards a standard data format, working with Building Smart, which is an international organization that's working on data standards. So there's really a lot to be done, but there's also a lot of work that's happening to push everyone in this direction. So with that, the phase 2 of the pooled fund study BIM for Bridges and Structures. The second solicitation is now open. Again, we finished our first phase, or we're in the near end of finishing our first phase, and we're looking for funds for our second phase. So if any of you DOTs are out there and are interested in this type of work, we're looking for $20,000 a year for 5 years, so $100,000 from each agency. And really what this gets you is a seat at the table, so you can learn what's going on and you can be part of the decision making moving forward. So if you have any questions about this, please feel free to reach out to Kyle Clute or Jim Hauber at Iowa DOT. They are running the pooled fund, the phase 1 and phase 2 study. So at New York State DOT, we showed you our first 2 pilot projects. So you can see on the screen our timeline. So we dabbled in that a little bit. We've gone back to our drawing board. We are working on our 3rd pilot project, which we're calling Hybrid Digital Delivery. This is a highway-only project. And then we're moving towards standardization for all of our projects. We've found that the model-based digital delivery is a big lift. It's a big lift in design and construction. It can be done. We've proven that, but we're scaling that back a little bit to try to essentially get all the low-hanging fruit for our projects and kind of ramp up while we wait for those data standards to become more used by the software themselves. So we're really hoping to see better interoperability between the software in the next few coming years, and we're hoping to ramp up our digital delivery at DOT accordingly. And then lastly, of course, our long-term goal is really to break down the silos, right? So we have all these data silos currently where everybody stays in their lane, design puts stuff together, it goes to construction, they have to recreate stuff, and then the same thing with asset management. So really the long-term goal is to make that information flow from throughout the whole planning process so that we're not recreating information as we go. So that's really our long-term goal. I think, as you can see, it's a big lift and we have a long way to go, but we're pushing and we're baby stepping in that direction. With that, there's all 3 of our contact information, and I think we're going to do a Q&A.
All right, thank you. Thank you for such a great presentation. Certainly, we have received a number of questions. Now, Paul is going to be moderating the question and answer period. I just wanted to add that this is exceptional. We are going to try to go to 25 minutes after the hour, because this is a really exciting, and New York DOT really have to be congratulated. You guys have taken basically the next leap. This is really good news, and hopefully other DOTs will follow. So we do understand that some people have a commitment. Now, the recording of this webinar will be posted on our website. So if you have to leave early, then please, by all means, come back and visit our website. So exceptionally, we are going to try to go to 2:25 because we've got lots of questions that came in before and also during the presentation. So Paul, it's all yours.
Okay, thank you, Torrid. Yeah, Jim and Brenda and Julianne, this is a really exciting project, as Torrid said. And we do have a number of questions that have come in, and some of them I'll try and paraphrase, or some of them are duplicates. So let's go ahead and get started. This first one came in ahead of time, and it says, does New York DOT have either an ABC checklist or a manual to determine projects for ABC techniques? Jim, you mentioned that in your first part about how you did it, but I didn't know if you had a manual or a checklist in that.
Yeah, so we have the New York State DOT Bridge Manual, which I can send a link afterwards. But within the manual, in the scoping section, we, as Julianne mentioned, we have the Drivers First initiative, and within that section, we do discuss various levels of accelerated bridge construction, depending on how much we want to compress the construction schedule. The Drivers First isn't just accelerated bridge construction in terms of precast components. It could be nighttime construction or double shifting. workforces. But then as you move into where you need to do this over a weekend, then, you know, we kind of guide you into, yeah, you gotta pre-construct your components and slide them in like we showed in Dinkle Road or other things like that. But the manual does discuss that in our scoping section, and I can send a link to that afterwards.
Okay, that'll be good. Then the other question came in ahead of time. What methods of ABC would also be applicable regarding this technology?
I don't know if Brenda, you want to take it or I can, it's up to you.
Sure. So I think digital delivery is applicable to, you know, anything we do, right? Whether it's ABC or our standard construction. So it's just a different way to convey the information to the contractor.
Okay. And real quick, like question came in ahead of time, has this technology been used over waterways? I think your first bridge was over waterways. So.
Yeah, certainly. We've done it in a variety of ways at various levels. We have different waterways. Obviously, we have streams and creeks up to you know, rivers that have tidal flow. All the details I showed certainly could be used over waterways, but on the creeks and smaller streams, we certainly use precast components, boxes, rigid frames, arch type structures that we put on, usually cast in place footings, and a lot of times we'll have precast wing walls. At the extreme end, we've floated in superstructures and erected them, at least in 2 cases I can think of, Crown Point up on Champlain and Willis Ave over Harlem River, where we've, you know, they pre-constructed the steel superstructures and floated them in, and then erected from, you know, onto the pre-made substructures.
Okay. We had a whole lot of questions about the software platform. And the first one here is what software platform was used is going to become a standard with most CAD platforms moving in this direction.
Right. So here at New York State DOT, we use Bentley products. So the format that we used for both of our pilot projects were Bentley, Bentley. So we used Open Roads Designer, Open Bridge Modeler. We used Synchro for the 4D analysis. And again, like I mentioned during the presentation, we're looking for that better interoperability. So some of our fabricators used AutoCAD, which we could make the conversions work, but it wasn't seamless. You know, we're looking to be able to transfer that legal, contractual information seamlessly, and that's what we're hoping for in the next couple years with the implementation of IFC throughout different software packages. That becomes a reality.
Okay. And then that question also came in, was this the same with the field staff and the contractors for visualizing the model?
Yep. So the field staff and the contractors, actually Bentley has a free software that's called Bentley View. So when we put information out contractually, we can't require a bidder to have to buy software to view our contracts. So like most of our stuff is a PDF, so Adobe has a free PDF reader. Bentley also has a free reader for MicroStation files and these files. So the contractor used that for bidding and for contracting, constructing the project, and our field staff used that as well. The only drawback with that is it is read only. So if you need to get in there and make changes or just try other things and play around with it, you can't do that with that software. So you would have to purchase the software if you want to make changes or additions to the files.
Okay. What if any were the supply chain problems regarding this technology? And that's maybe along the lines of the programs and the computer equipment, and also access to the computer equipment if you're in a real rural area or something in a field office.
Yeah, so I guess I can speak first to the supply chain issues. So the first pilot project, Route 28 over Sopas Creek, we didn't have any supply chain issues. That was constructed in 2020, 2021. And for East 138th Street, we haven't had any issues with that just yet. One thing that we do here in New York State DOT is we try to avoid lettings in the fourth quarter for our bridge replacement projects. So that means that we want to get this out to the contractors early enough so that when they are awarded the contract, they don't have an issue with procurement of structural steel or prefabricated components. So that's something that we've been doing for years here in New York State DOT, and I think that has also helped in the current climate that we're in. Okay.
Then Julianne, the question came in about were there other solutions for applying, or what other solutions for applying zero load to the utilities were considered?
Yeah, so we went through some extensive preliminary design options before we really landed on our carry beam system. The first thing that we really tried to do was to keep everything embedded within the concrete abutment itself. We had to work very closely with New York City DEP on maintaining clearance to their infrastructure. They obviously don't want us building anything directly adjacent to it. So, encompassing that system within the concrete abutment was our first choice. We looked at, first just heavily reinforcing the abutment. Could we get away with that? Could we look at doing some sort of pre-stressed or post-tension abutment stem? We looked at that. And then eventually we kind of ended with an embedded carry beam system, but we really didn't have a lot of depth. So because vertical clearance was an issue at this site, we didn't have a lot of room to raise the profile. So there just wasn't enough room within the abutment stem for the carry beam structure. So that's how we kind of ended up with the carry beam below the abutment footing.
Okay. We'll look at some construction questions real quick, or construction issues. How do the field construction office receive the digital plan data?
Right. So, having your field construction up to speed is super important, right? So we spent a lot of time working with our construction group during design. So they were aware this was coming during design. And then after the contract was awarded, we brought our field staff into the office along with our contractor. And we spent 2 days with them going over the contractual information. So we had presentations where we went through and we showed them all the information. And then we had, just open sessions of, what do you need help with? What are you struggling with? What can't you find? And we did these 2-day sessions separately. So we brought them in, we gave them all the information, we sent them home, we let them digest it, and then they came back and we spent another day going with them over just getting them familiar with the model. So like I mentioned during the presentation, it's extremely important to have field staff who understand how to use the model. And, we staffed accordingly and it worked out well for us.
Okay, and the second part of that question here was what training was provided to the field officers? You kind of told us about what you did and how you brought them in and everything else. So I think that will get go on.
In addition to that too, obviously it wasn't just a handoff from design to construction and you guys are on your own. Any questions they had in the field, design has been for both projects. We're involved in any issues or coordination that go on throughout. So design was committed throughout construction to support both of the projects.
Okay. We got some questions here that came in during the session and they're pretty interesting. The first one, I guess, Jim, for the precast decks on steel beams where the section was inverted for casting, how do you handle camber on those units?
That's factored into the design when they cast upside down. They account for that when they flip it over the pre-compression.
Okay. Then the next one was please describe the reception of digital plans from the construction industry.
Right. So I mentioned during the presentation that we met with our local AGC, 4 times prior to advertising the project, and we got a lot of interest. There's a lot of contractors out there that were interested, and the fabricators as well. Like I showed you, we had 5 bidders on our first project. So, we saw a lot of interest, and they know that we're moving in this direction, and they're really interested too in what makes their work more efficient. And again, saving money is what makes all of our work more efficient. So everybody's interested in ways that we can do that.
Okay, then here's one that came in during your session. With plans being digital, what do you do for as-builts?
It's the question that everybody asks every time. And it's a great question, right? And everybody is used to getting a PDF with as-built. And what we're doing is we're documenting any field changes that go along, so the model gets updated throughout construction if need be. And then our as-built are digital as-built. So the same format that we had for our construction contract is what we're going to have for our as-built plans at the end of the day. But we also consider other use cases down the end of the road. And one of the big ones is bridge inspection, right? So we go out every 2 years and we send inspectors out there to look at our bridges. And we don't expect them necessarily to jump into a giant 3D model of our bridge every time they go out there. So in this, I would call interim period where we're still working on our information transfer for asset management, we provided what I would call a reduced plan set with typical sections and just some information for bridge inspectors that they would need. So we do have digital as-built, but we also have supplemental information that we're providing for other use cases downstream.
Okay, let me get 3 more here real quick, and I'm going to turn it over to Jugash. First one was, please describe specifications as part of the electronic plans. I think you showed something like that around sheet 30. You showed where the specifications were in there, somewhere around that sheet.
Yeah, so one of the big things that we do with our digital delivery is we are trying not to change our process, right? So essentially, we change the definition of the term plans, and everything else remains the same. So we're not trying to reinvent the wheel. We're not trying to create a whole new process for every piece of the project with digital delivery. So we didn't have, we had a special note in the project which gave more information, but we did not have any different specifications than we normally would in a project.
Okay. How are steel girder camber diagrams handled in 3D projects?
So, yep, we provided those in Excel format. So it wasn't a 2D, it wasn't a PDF, but we provided it as an Excel sheet for the fabricator.
Okay. Then, is there a way to convey the accuracy of underground utility locations? Particularly, some utilities may be precisely located, while others may be just estimated locations.
Yeah, so that's a really good question. So we actually spent a lot of time researching existing record plan information for existing utilities. And we did a lot of field investigation to verify the existing record plan information because we felt that was very important for this project, especially because the utilities needed to go in very specific locations and how they interacted with the structure itself. So we spent a lot of time verifying that information. I don't know if that's possible on every project, but specifically for this one, we did have a lot of confidence in the utilities surrounding the bridge itself.
Okay, it's about a little after 20 after. I'm going to turn it over to Jugash, and maybe he can pick up another question or two. Jugash?
Okay, Paul, thank you very much. First question is, describe how construction personnel handle the electronic plans.
Right, so our construction personnel had access to the exact same information that the contractor did. They had tablets were issued to them out in the field, so they could use those in the field office or when they were out, at the project location as well. This seemed to work pretty well in both instances, so they had the contractual information on the computer or tablet in front of them when they needed.
Okay, thank you.
And I'll just add
Go
to
ahead.
that, for the East 138th Street project, we've been meeting biweekly with the construction field staff representing design. And, towards the end of last year, the beginning of construction, we had to do a lot more screen sharing with the model, and we would show them. And we're at the point now where I don't need to bring up the model at all during our meetings, that the field staff are really driving those conversations and using the models as they should be. So I think it's been a good learning experience.
Okay, thank you. Is there a way to convey the accuracy of underground utility locations? Some utilities may be precisely located prior to construction, while others might be just estimated locations.
Yeah, so I think that we covered that a bit there's going to be times where we don't know precisely where every single utility is located, but I really don't think that's a difference between a conventional 2D plan project or a digital delivery project. Sometimes you do have surprises that you uncover underground, but everything in the immediate vicinity of the structure, we did a lot of investigation, field work ahead of time to make sure we had more confidence in those locations.
Okay. Are the construction documents for 138th available to the industry through New York State DOT website?
So as long as you write down the two contract numbers that are listed here, you can do a quick Google search and you can find all the contractual information for both projects.
Okay. Last question, what software was used by field staff / contractor for visualizing the model?
Right, so they're using Bentley products, whether that's the free Bentley View product that I know the contractor used for the first pilot project. The field staff had MicroStation and OpenRoads available to them, and they used those when needed as well.
Okay, thank you very much. I believe I'm at the end of my time, so I'll turn it back to Adirond.
All right, thank you. Thanks everyone. Thanks to our speakers. Certainly this was a very exciting project. We got lots of questions. So long.
Thank you.